Hello students, I Pawan Sharma, teacher of chemistry from Rishikul Vidyapith, coming with fourth lecture of solution unit. In third lecture, I discussed colligative properties. In colligative properties, I discussed first colligative properties, that was relative lowering of vapor pressure, and other name of that is Raoult's law for solution containing non-volatile solute. Earlier that I discussed one concept, that is Raoult's law for solution containing volatile solute, or I discussed Raoult's law for liquid solutions. Before further discussion in colligative property, first I will complete this concept, ideal solution and non-ideal solution. Liquid solution. Liquid solutions. Now liquid solutions means both the components, solute as well as solvent. Suppose this liquid A, that is solvent, this liquid B, this is solute. Both solute and solvents we are taking liquids. In such case, one concept we have discussed, that is Raoult's law. That is Raoult's law. Raoult's law. Or you can say liquid solution can be classified into two categories, ideal solution and non-ideal solution. Students, I think clear to you. Or you can say, because this we are taking both liquid, it means both are volatile. Or you can say when in solution both components are volatile, or you can say both components are liquid. In such cases, we can divide such solutions into two categories, ideal solution and non-ideal solution. That is why we are discussing ideal solution and non-ideal solution. First I will take ideal solution. What are ideal solution? For solution to be an ideal, some conditions are to follow. You understand like this. I am taking here liquid A. Here I am taking liquid B. Or you can say this is solvent. This is solute, and when they combines to each other, then solution will be formed. Liquid solution will be formed. Then this is solution, where both components A and B are present. Now for liquid, or you can say whether solution is ideal or non-ideal. Some condition we have to check. What are these conditions? First we have to check Raoult's law. We have to check Raoult's law. Second, we have to check interactions. In third condition, we have to check delta V, mixing, change in volume on mixing. Fourth condition, we have to check delta H, mixing, enthalpy change during mixing. Here, now ideal solution. First condition and most important condition, ideal solution should obey Raoult's law. Raoult's law. At every stage, Raoult's law should be obeyed. And what is Raoult's law? That is each component's P, vapor pressure of a solvent, that is equal to P naught A Xc. This is obtained from Raoult's law. And this PA, that is observed vapor pressure, or by experiment. Or you can say both vapor pressure, which is from, this comes from Raoult's law, and this comes from reality, or this comes from experiment, that should be same. Like that, PB, that should equal to P naught B XB. That is from Raoult's law, and it is from experiment. Also like this, PS, that is equal to P naught A XA, P naught B XB. This is the first condition. That is most important condition. Ideal solution is that one which obey Raoult's law in all respect. Now come to the second condition. You may note down, students. Second condition. About the interactions. Or you can say about the force of attraction. Okay. Now second condition about the interaction. Now this is solvent, or here there is a interaction between solvent molecules, that is represented by A interaction, and in solute molecules here interaction is BB interaction. Or you can say when you take pure solvent A, then there is an interaction between solvent. Here there is an interaction between solute. Now after mixing, there is a solution. Now another kind of interaction here, that interaction is AB interaction, or you can say it is the interaction between solute and solvent. Ideal solution is possible only when interaction between solvent or interaction between solute, that must be equal to the interaction between solute and solvent. Same interaction. Come to the third condition. Delta V mixing, that should be zero. You can understand like this. Now if we take 50 ml of liquid A, 40 ml of liquid B, then after mixing it comes out to be 90 ml. On that case, delta V means that is change in volume. How we can calculate? That can be calculated like this: product volume minus reactant volume. This is reactant and this is product. This is the product of solute and solvent, that is solution. And in product, what is the volume? That is 90 ml. And reactant, what is the volume? 50 plus 40. 50 plus 40. That is also 90. And result will be 0. I think, friends, is it clear to you? This comes out to be 0. Delta V mixing should be 0. Now third condition. Third condition we have covered. Now Fourth condition, delta H, or you can say enthalpy change on mixing, that also should be zero. How you can consider it? Now there is an interaction between A, here interaction between BB, and new interaction A and B. Here we are to break these interactions, here we are to break these interactions, and new interaction we are to form. Now when these bonds are broken, then what happens? Heat is absorbed. Here heat is absorbed, and here heat will be released because bonds are formed here. Now suppose here 40 kilojoule energy is required, here 30 kilo energy is required. That total energy required, that is 70. Now in the bond formation, same energy is released, that is 70. So result will be 0. Or you can say there is no evolution or no absorption of heat during mixing. Or you can say simply there is no exothermic process, there is no endothermic process. Such solutions are called ideal solution. Or this condition, if any solution obeys, such solutions are called ideal solution. I repeat students, first condition for ideal solution, Raoult's law should be obeyed. Second condition, interaction should be same. Solute-solvent interaction, solvent-solvent interaction, and solute-solvent interaction. Third condition, students, delta V mixing should be 0. Fourth condition, delta H mixing also should be 0. Such solutions are called ideal solution. Now come to the case of examples. Or you can say generally dilute solutions are considered as ideal solution. Take some examples. Examples of ideal solution. Examples of ideal solution. Examples of ideal solution. Examples of ideal solutions. I take first example, that is benzene. This is the formula of the benzene, and toluene. Benzene and toluene. First example. Second example, you take n-hexane and n-heptane. Third example, you take methanol and ethanol. Fourth example, you take chlorobenzene and bromobenzene. इन एग्जाम्पल से आप एक कंक्लूड कर सकते हैं दोनों कंपोनेंट्स में ऑलमोस्ट पोलरिटी सेम है. नॉन पोलर, पोलर, this is polar, this is polar. Same polarity, same nature substance we are to take on. Now if I take the example here chlorobenzene and if I put here iodobenzene, then this example will not be ideal. Or you keep in mind only one step you are to increase. Now chloro है तो यहाँ क्या होगा ब्रोमो, अगर यहाँ ब्रोमो है तो यहाँ क्या होगा आइडो. Only that should be difference. Also like this n-hexane and this is n-heptane. यहाँ कितने कार्बन हैं 6, यहाँ कितने कार्बन है 7. Only one jump. If we put here n-hexane, here octane, then in such case solution can't be ideal. I think clear. You can remember like this. These are the ideal solution. Now come to the graphical representation of ideal solution. Graphical representation. See. graphical representation. Graphical representation. Graphical representation. We are to take two components. This side we take vapor pressure. This side also we take vapor pressure because we are taking solute and solvent. Both are liquid, for ideal solution. Here you take composition. Composition is mole fraction. Mole fraction. Start like this. X mole fraction of solution. What is that? XA plus XB. That should be 1. Maximum value is 1. Now if here we put XA is equal to 1 here. XA is equal to 1 here. In such case, XB, what will be XB? 0. Or you can say only one component will be present here. In such case, there is a, or you can say at here, there is a pure liquid A present here. Solvent is present here, pure. Now, if we move here, we decrease the value of XA and we increase the value of XB. And here, we can write here XB is equal to 1. XB is equal to 1. In such case, XA will be 0. Clear? Or you can say only one component is present here, that is also pure. Or you can say this is pure liquid B. Pure liquid B. Pure liquid B. And for ideal solution, Raoult's law must be followed. What is Raoult's law? PA is equal to P naught A or XA. In a solution, each component that depend upon mole fraction. P naught A pure के लिए that is mole fraction. Now if XA is equal to 1, students, XA is equal to 1, put here, then what will be? PA is equal to P naught A. P naught A. Or you can say that's like a pure substance. And vapor pressure will be maximum. So this is P naught A. P naught A. Now, if XA is equal to 0, students, XA is equal to 0, then put here, then this will be PA is equal to P naught A, XA क्या है? 0. So this will be 0. Vapor pressure will be minimum and this will be, when XA is equal to 0, vapor pressure is here, 0. Now if we increase the value of XA, then vapor pressure goes on increase. When it comes at 1, it will be maximum and graph may be like this. This is PA is equal to P naught A XA. Clear? Like this, XB is equal to 1. So you know PB is equal to P naught B XB. Putting value of XB 1, then what will be that? PB is equal to P naught B. Like this we can write here. This is P naught B. P naught B. And when XB is equal to 0, then vapor pressure is minimum, that is 0, and we can do like this. Clear? And this is PB and this is P naught B. This is XB. And like this. And this is for PS is equal to PA naught XA, PP naught B, XB. This is graphical representation for ideal solution. So far I have covered ideal solution. First I revise it. Ideal solution, which obey Raoult's law. Delta V maximum is 0, delta H maximum is 0, and interaction are same. in the pure components as well as component of solution. After that I discussed example, and this is graphical representation. Students, now we will discuss non-ideal solution. After discussion of ideal solution, we are discussing non-ideal solution. Non-ideal solution. That is reverse of non-ideal solutions, students. Non-ideal solutions. A reverse of ideal solution. In ideals, Raoult's law is obeyed, but here Raoult's law will not be obeyed. No obey of Raoult's law. Or you can say Raoult's law is not obeyed here. Raoult's law is not obeyed. Is not obeyed. Second, interaction between solvent. Interaction between solute are not equal to the interaction between solute and solvent. Third condition, delta H mixing, or you can say it can't be zero here. Fourth condition, delta V mixing, that also can't be equal to zero. Sorry, delta H mixing can't be zero. Delta V mixing can't be zero. And such solution are non-ideal solution. In non-ideal solution, for there is two categories, positive derivation and negative derivation. It will cover in next lecture. Before that, we will go through it, and thank you for my side. Have a nice day.